Hi, I'm going to solve the integral of tangent of 9x over x dx. So I already started this a little bit. So first I'm going to do a u substitution on the square root of x. U equals square root of x, which is the same thing as u equals x to the 1/2. The derivative of x to the 1/2 is 1/2 x to the negative 1/2 dx, which is also equal to 1 over 2 square root x dx. When you multiply both sides by 2 here, you get 2 du is equal to 1 over square root x dx. And that's going to replace the square root x dx here when we sub that in, bring the 2 out front right away, and get 2 times the integral of tangent of 9u du. From here, you actually could solve it right away if you had the integral of tangent of ax. Memorize the integral of tangent of ax dx is equal to the negative 1 over a times the natural log of the absolute value of cosine of ax. But you don't have to know that to solve this. I'm just going to use a few more u substitutions. I'm going to use different variables so it's less confusing. But I'm going to use w here. So I'm going to set w equal to 9u. The derivative of w dw is going to be equal to 9 du. We're going to divide both sides by 9 to get 1/9 dw is equal to du. So then I'm going to be able to swap out 9u for w, and I'm going to be able to swap out du for 1/9 dw. I'm going to bring 1/9 to the front right away. So when I bring this in, I'm going to have 2/9 times the integral of tangent of w dw. And then I'm going to rewrite that just to make this easier, because again, if you don't know the integral for tangent off the top of your head, this is still solvable. So this is the integral of sine of w all over cosine of w dw. From here, I'm actually going to use another u substitution. I'm just going to use z, just a variable that I like to use in this situation where you have a triple u sub. So I'm going to set z equal to cosine of w. And so then the derivative of that, dz, is going to be equal to negative sine of w dw. I'm going to multiply both sides by -1 or divide by -1 to get negative dz is equal to sine of w dw. So then I'm going to be able to swap that in. Sine of w dw is going to be replaced by negative dz. I'm going to bring the -1 out front right away to get negative 2 over 9 times the integral of 1 over z, because the cosine of w swaps in for that, dz. So then from here, we just have 1 over z, which is the same as z to the negative first. And the integral of 1 over z is going to be the natural log of the absolute value of z. So when you take this, you're going to just get negative 2/9 times the natural log of the absolute value of z plus c. From here, we just have to back substitute all of these substitutions, which doesn't take too long. This just gets negative 2/9 times the natural log of the absolute value z first cosine of w, which is equal to negative 2/9 natural log cosine. And I'm just going to do both these at once to make this a little bit faster. W is 9u, u is the square root of x, so cosine of 9 square root x plus c. And so there you have the integral of tangent of 9 square root x all over square root x dx is equal to negative 2 over 9 times the natural log of the absolute value of cosine of 9 square root x plus c. I hope that helped.